Remember, whenever you square both sides of an equation, you may introduce what are called extraneous solutions. So whatever solutions you get, you want to check back into the equation. If it makes a true statement, then that is a solution. But if it makes a false statement, that is an extraneous solution. I'm going to solve this equation for x. The square root of x plus 7 minus 5 equals x. So you want to isolate the radical to one side, move everything else to the other side. So that negative 5 needs to be moved to the right-hand side. Add 5 to both sides. When you do that, to get the square root of x plus 7 equals x plus 5. You need to get rid of the radical sign, so do the opposite of square root, and that is to square both sides. If you square the square root of x plus 7, that is x plus 7. And if you square x plus 5, you're multiplying x plus 5 by x plus 5 with the FOIL method or distributive property. That would be x squared plus 10x plus 25. That is a quadratic equation, so you want to get everything to one side equal to 0 to solve for x. We're going to subtract x and subtract 7 from each side. When you do that, get x squared plus 9x plus 18 equals 0. So that'll factor into two binomials. The first terms of those two binomials are x. The second terms multiply to make 18 and add to make 9. So two numbers that multiply to make 18 and add to make 9, it's going to be 6 and 3. So that factors into x plus 6 times x plus 3. These two multiply together to equal 0, so that means either one of those could be equal to 0. So set x plus 6 equal to 0 and x plus 3 equal to 0. Then solve those two equations for x, and that first one subtract 6 from each side, get x equals negative 6, and the second one subtract 3 from each side, get x equals negative 3. Now we did square both sides as we're working through this, so we may have introduced an extraneous solution. We're going to check both of those solutions back in, see if they make a true statement. It's going to start with negative 6. If you put negative 6 back into that original equation for x, you'd have the square root of negative 6 plus 7 minus 5 equals negative 6. Well, the square root of negative 6 plus 7 would be the square root of 1, and that is going to be 1. So you have 1 minus 5 equals negative 6. That's a false statement. 1 minus 5 does not equal negative 6. That would be negative 4 is equal to negative 6, and that's a false statement. So that's telling you that negative 6 is an extraneous solution. So right there, we did all the right steps to get to that negative 6, but when you put it back in, it doesn't work. That is an extraneous solution. I'm going to check the negative 3 back in. So if you substitute negative 3 back in for x, you'd have the square root of negative 3 plus 7 minus 5 equals negative 3. Combine negative 3 and 7 under the square root sign. That would be 4. So it'd be the square root of 4 minus 5 equals negative 3. Well, the square root of 4 is 2. So 2 minus 5 equals negative 3, and that's a true statement. 2 minus 5 does equal negative 3. Both sides equal each other. That solution satisfies that equation. That means negative 3 is a solution. So x equals negative 3, but x equals negative 6, that is an extraneous solution. What is the solution of the square root of 2x minus 6 equals 3 minus x? We have the radical sign isolated to one side, everything else is to the other side. Now we just need to get rid of that radical sign. So to get rid of that radical sign, it's a square root. So the opposite of square root is squaring both sides. So if you square the square root of 2x minus 6, that is 2x minus 6. And if you square 3 minus x, going to use the FOIL method or distributive property, multiply 3 minus x by 3 minus x, and that is 9 minus 6x plus x squared. That is a quadratic equation. You want to get everything to one side equal to 0. Try to keep your x squared positive. That's a good habit. So we're going to subtract 2x and add 6 to both sides. When you do that, get x squared minus 8x plus 15 equals 0. That'll factor into two binomials. The first terms of those two binomials are x. Second terms multiply to make 15 and add to make negative 8. So two numbers that multiply to make 15 and add to make negative 8 would be negative 5 and negative 3. So that factors into x minus 5 times x minus 3. Those two multiply together equals 0. So set each one equal to 0. Set x minus 5 equal to 0 or x minus 3 equal to 0. And then solve each one of those for x. And that first one x equals 5 and the second one x equals 3. But we did square both sides as we're working through that. So you want to check for extraneous solutions. I'm going to start with that 5. We're going to substitute 5 back in for x into that original equation. Make sure you put 5 in for both x's up there. This will be the square root of 2 times 5 minus 6 equals 3 minus 5. Well, 2 times 5 is 10, so it would be the square root of 10 minus 6 equals negative 2. 10 minus 6 is 4, so it would be the square root of 4 equals negative 2. We're only taking the positive square roots. So the square root of 4 is 2, and that is not equal to negative 2. So 5 in it is an extraneous solution. I'm going to check 3 back in. So if you put 3 back in for x into that original equation, it'd be the square root of 2 times 3 minus 6 equals 3 minus 3. Well, 2 times 3 is 6. So under the square root sign, that is 6 minus 6, which is going to be 0. On the right, that's 0. Square root of 0 is 0. So 0 equals 0. That's a true statement. That means 3 is a solution. So 3 is a solution, and 5 is an extraneous solution. Going to solve the square root of 11x plus 3 minus 2x equals 0. So you want to isolate the radical to one side, move everything else to the other side. So that negative 2x needs to be moved to the other side. To do that, you're going to add 2x to both sides. And when you do that, you get the square root of 11x plus 3 equals 2x. Now you just isolated the radical to one side, so the next step is to get rid of the radical sign. Do the opposite of square root, and that is to square both sides. So if you square the square root of 11x plus 3, that is 11x plus 3. And if you square 2x, make sure you square the 2 and the x, that would be 4x squared. So you have 11x plus 3 equals 4x squared. Now that is a quadratic equation, so you want to get everything to one side equal to 0. Try to keep the x squared positive for factoring reasons. It's going to subtract 11x and subtract 3 from each side. So that makes 4x squared minus 11x minus 3 equals 0. Now the coefficient of x squared is something other than 1, so we have to do factoring by grouping. The coefficient of x squared is 4 here. So we're going to split that negative 11x into two terms. Those two terms, their coefficients, will multiply to make what 4 times negative 3 is. So they multiply to make negative 12, and they add to make negative 11. So two numbers that multiply to make negative 12 and add to make negative 11 would be negative 12 and positive 1. So the coefficients on those two terms that you split that negative 11x into, again, multiply to make what 4 times negative 3 is, and add to make that middle coefficient. So the two coefficients are negative 12 and 1. So we split that into negative 12x and x. Now the reason it's called factoring by grouping is because of this next step. We're going to group those first two terms together and factor out the common factor of 4x. So if you factor 4x out of the first two terms, you have x minus 3 in parentheses. Then the last two terms group together and factor out a common factor there. Now you might look at that x minus 3 and say, well, there's nothing to factor out. You can always factor a 1 out. So if you factor 1 out, get again x minus 3 in parentheses. You have to get the same thing in the parentheses for this to work. So the next step is to take out what's in the parentheses. Factor out that x minus 3. So if you take that x minus 3 out, you're going to be left with that 4x plus 1. So that factors into these two binomials, 4x plus 1 times x minus 3. So those two multiply together to equal 0. That means either one of those could be 0. So set each one equal to 0. Set 4x plus 1 equal to 0. And also x minus 3 equal to 0. Solve each one of those. In that first one, subtract 1 and divide by 4. Get x equals negative 1/4. In the second equation, add 3 to both sides. Get x equals 3. But we did square both sides as we worked through this. So you want to check for extraneous solutions. I'm going to start with that negative 1/4. Substitute negative 1/4 back into the original equation. So if you take 11 times negative 1/4, fun times with fractions. 11 times negative 1/4, that is negative 11/4. And then you have a plus 3, so we're getting a common denominator there of 4. Common denominator is 4. That's going to be negative 11/4 plus 12/4. And then you still have negative 2 times negative 1/4. That would be a positive 1/2. So negative 11/4 plus 12/4, that is going to be 1/4. Square root of 1/4 would be 1/2. 1/2 plus 1/2 is not 0. That's an extraneous solution. Next, check the 3. So if you substitute 3 in for x, it'd be the square root of 11 times 3 plus 3. And then minus 2 times 3. So 11 times 3, that is 33, be the square root of 33 plus 3, it's the square root of 36. And then this negative 2 times 3 is negative 6. Well, the square root of 36 is 6. So it'd be 6 minus 6, which is 0. Both sides equal each other. That makes a true statement. That means 3 is a solution. So 3 is a solution, and negative 1/4 is an extraneous solution. If an equation contains two radical signs, we're going to isolate the more complicated looking radical first, then eliminate it, and then proceed to solve for x. So we have the square root of 2x plus 1 minus the square root of x equals 1. If you look at those two radicals, which one looks the most complicated? I'd say the square root of 2x plus 1 looks a lot more complicated than the square root of x. So we're going to eliminate that radical sign. To do that, we're going to move that square root of x to the right side. So we're going to add the square root of x to each side. If you do that, get the square root of 2x plus 1 equals the square root of x plus 1. Now we just isolated that square root of 2x plus 1. We're going to eliminate that radical sign. So to eliminate that radical sign, we're going to square both sides. If you square the square root of 2x plus 1, that will just be 2x plus 1. On the right, if you square the square root of x plus 1, we're going to multiply that by itself. We have to use the FOIL method or distributive property. So using the FOIL method or distributive property, when you multiply the square root of x plus 1 by itself, that's going to be x plus 2 times the square root of x plus 1. So we have that radical sign eliminated on the left side, but now we have to eliminate this radical sign. So we're going to move everything from the right to the left side. I'm going to subtract x and subtract 1 from each side. When you do that, get x equals 2 times the square root of x. Now to eliminate that radical sign, square both sides. If you square the x, that's x squared. And if you square the 2, that's 4. If you square the square root of x, that will just be x. So you have x squared equals 4x. That is the quadratic equation. To solve that for x, you want to get everything to one side equal to 0. So subtract 4x from each side. Get x squared minus 4x equals 0. Always look for a common factor that you can factor out. X is a common factor of those two terms. So factor an x out. When you do that, get x times x minus 4 is equal to 0. Those two multiply together to equal 0. So set each of those two equal to 0. Set x equal to 0. Also x minus 4 equal to 0. Solve each one of those for x. Well, the first one's already done. X equals 0. And the second one, add 4 to both sides. Get x equals 4. So x equals 0 or 4. But we did square both sides as we're working through this. So we may have introduced an extraneous solution. So we're going to check those back in. Substitute 0 back in for x into that original equation. Be the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. Well, 2 times 0, that is 0. Plus 1, that's 1. Be the square root of 1. And then minus the square root of 0, that doesn't matter. It's not going to change anything. Just square root of 1 equals 1. Well, 1 equals 1, that's a true statement. That means 0 is a solution. But we still need to check the 4 back in. If you substitute 4 back in for x, be the square root of 2 times 4 plus 1 minus the square root of 4 equals 1. Well, 2 times 4 is 8. So be the square root of 8 plus 1, which is the square root of 9. And minus the square root of 4 would be minus 2. So the square root of 9 is 3. 3 minus 2 is 1. 1 equals 1. Both sides equal each other. That means 4 is also a solution. So x equals 0. Also x equals 4. Well, that looks like fun. Square root of 2x plus 6 minus the square root of x minus 1 equals 2. We have two radical signs in this equation. You want to isolate the most complicated looking radical first, then eliminate it, and then proceed to solve for x. So I'd say the square root of 2x plus 6 looks more complicated than the square root of x minus 1. So we're going to isolate that square root of 2x plus 6 by moving that square root of x minus 1 to the right side. So add the square root of x minus 1 to each side. When you do that, get the square root of 2x plus 6 equals 2 plus the square root of x minus 1. It's going to eliminate that radical sign on the left by squaring both sides. So if you square the square root of 2x plus 6, that is just going to be 2x plus 6 on the left. On the right, you have to use the FOIL method or distributive property. You're squaring 2 plus the square root of x minus 1. So multiply that by itself with the FOIL method or distributive property. Again, on the left, that's just 2x plus 6. On the right, when you use the FOIL method or distributive property, multiplying 2 plus the square root of x minus 1 by itself, you'll get 4 plus 4 times the square root of x minus 1 plus x minus 1. Now on the right side, you can combine those like terms. 4 and negative 1, that makes 3. So it'd be x plus 3 plus 4 times the square root of x minus 1. On the left, nothing changes, still 2x plus 6. Now we're going to isolate this radical sign by moving everything else to the left side. It's going to subtract x and subtract 3 from each side. When you do that, get x plus 3 equals 4 times the square root of x minus 1. So we isolated that radical sign. Now we're going to eliminate that one. And to eliminate that radical sign, we're going to square both sides. Now on the left, you're squaring x plus 3. So multiply x plus 3 by x plus 3. That would be x squared plus 6x plus 9 on the left. On the right, you're squaring 4 is 16. And if you square the square root of x minus 1, that is x minus 1. So again, on the left, that is x squared plus 6x plus 9. And on the right, that is 16x minus 16. Going to move everything to one side, get it equal to 0. So subtract 16x and add 16 to both sides. When you do that, get x squared minus 10x plus 25 equals 0. That'll factor into two binomials. The first terms of those two binomials would be x. The second terms multiply to make 25 and add to make negative 10. So those second terms will be negative 5 and negative 5. So you have x minus 5 times x minus 5 equals 0. Well, we don't really have to set each one of those equal to 0. It's the same thing. So just set x minus 5 equal to 0. And then finally, x equals 5. So substitute that back in because we did square both sides a couple times as we're working through this. You want to substitute that back in, see if it makes a true statement, make sure it's not extraneous. So if you put 5 back in for x into that original equation, make sure you hit both x's with that 5. Be the square root of 2 times 5 plus 6 minus the square root of 5 minus 1 equals 2. So 2 times 5, that is 10. Be the square root of 10 plus 6, which is square root of 16. And 5 minus 1 is 4. So square root of 16 is 4. Square root of 4 is 2. 4 minus 2 is 2. 2 equals 2. That's a true statement. That means 5 is a solution.